6.5 is about solving square roots and other radical equations. Now, like everything else, you knew what we were working towards was eventually solving these things. What you want to do is make sure we isolate the square root first. So let's do this. So the square root of 2x minus 3 equals 8 minus 3, which is 5. Opposite of square rooting something is squaring it. So let's go ahead and square that. And that gives me 2x minus 3 equals 25. Then you just solve from there. Add 3, 2x equals 28. Divide by 2, x equals 14. Now, like everything else, you should probably take 14 and plug it back in just to make sure it works. Problem 2, all right, it's the same difference. There's no thing, we have to isolate the radical first. Now, the 2/3 exponent kind of looks funky because it's not a radical, but it is the same stuff. So let's divide by 3 to get it by itself. So we can cancel that out. We end up with x plus 1 to the 2/3 equals 4. Okay, well, how do we solve? Well, like anytime we have fractions, you should automatically think reciprocal. Well, the reciprocal of 2/3 is 3/2. And 4/3 the 3/2 power. Again, you can plug that right in your calculator. That cancels out. We'll end up with x plus 1 here. And you end up with 4 to the 3/2 power. Now, again, you're going to end up taking the square root because it's a half. So whenever you take the square root of both sides, remember it equaled plus or minus that answer. So 4 to the 3/2 power is 8, but it's plus or minus 8 because of that even root right there. Okay? Now solve. Well, you get subtract 1, subtract 1. So I get x equals 8 minus 1, and x equals negative 8 minus 1. Okay, so there's two answers here. Again, as we go through this, you end up with 8 minus 1, or x equal to 7, and negative 8 minus negative 1 is negative 9. There are two answers. Problem 4. Again, same steps. Isolate the radical first. Well, how do I isolate the radical? Add 5. Add 5. I get the square root of x plus 7 equal to x plus 5. What do I do now? Well, I got to get rid of the square root. How do I do that? I go ahead and square both sides. Again, we're back to squaring both sides. So that gives me x plus 7 over here. How do I solve that stuff? Well, let's take our shortcut either based on Pascal's triangle, everything else that we've learned about binomials. You square the first, you square the last, combine the two, which gives me 5x, and double it. That's how I get 10x. Okay, well, now we got to go ahead and solve. So let's subtract x. And let's subtract 7. Subtract 7. I get 0 equals x squared plus 9x plus 18. And then go ahead and solve. Again, there's various ways. We've got a quadratic. Okay, now we have to solve a quadratic. Now, you could do it in your calculator. You do it any way you want. I don't really care how you get it down to solve. That's fine, but let's do it solve by factoring. My AC number is 18. What's going to give me 9 was 18. Well, 6 and 3. So that's going to factor out to x plus 6 times x plus 3 equals 0. Set each one equal to 0, so x plus 6 equals 0, and x plus 3 equals 0. So x equals negative 6 and negative 3. Now, you got to make sure you check, because this is where we talk about extraneous solutions. Now, I boxed this, so I kind of jumped the gun a little bit, but what I need to do is plug it back into my equation, see if it works. Okay, so again, plug it in. So I get the square root of negative 3 plus 7 minus 5. Does that equal negative 3? Well, just figure it out on the left side. That's pretty simple to do. You end up with negative 3 equals negative 3. So that works. So negative 3 is an answer. Well, let's check negative 6 now. Again, plug it in. Square root of negative 6 plus 7 minus 5. Does that equal negative 6? When I figured it out, what I end up with on the left side is negative 4. And obviously negative 4 does not equal negative 6. So the only answer to this problem is negative 3. That's why you have to check for extraneous solutions. The last problem, now, again, you want to follow the same steps. You want to isolate the radical. So plus radical x plus radical x. Why am I isolating? Because I'm isolating the main radical. Actually, I'm isolating both radicals as best as I can. So I get the square root of 2x plus 1 equals radical x plus 1. Well, how do I get rid of it? I'm going to go ahead and square both sides. That's going to give me 2x plus 1 on the left side. Again, we have a binomial, so let's square the first. Let's square the last, plus 1. Let's combine them, 1 radical x, and double it. Okay, so we end up with 2 radical x in the middle. Well, how do I solve now? Again, we're going to carry that same philosophy through. Isolate the variable. Subtract x. Subtract 1. That's going to get rid of everything on that side. 2x minus x is x. 1 minus 1 is 0, so that's gone. Equals 2 radical x. Okay? Well, how do I get rid of the square root now? Now, you should isolate the variable, but moving it to the other side is not really going to help matters much. So I can go ahead and get rid of that now if I want to and square it. You end up with x squared equals, well, 2 squared is 4. Square root of x squared is just x. Okay, well, let's go ahead and solve. Again, it's a quadratic, so it's got to equal to 0. Subtract the 4x over. I get x squared minus 4x equals 0. And then factor. Again, you could plug this in your calculator. I don't really care how you solve it. This is not the concept here. But let's pull an x out. Times x minus 4 equals 0. I get x equals 0. And I get x minus 4 equals 0. So x is 0 works, and x equals positive 4. Again, plug it back in. Make sure they both work. Okay? And as you go through, and you'll find out that they both work. So your solutions are 0 and 4.